Hello everyone, this is pretty much our final lesson for Crops 2, delving into petunia production. It's kind of interesting. I mean, every crop's got its own interesting elements, and there's some little twists in petunias, so let's have a look. What is the connection here, right? We got eggplants, McDonald's French fries, petunia hanging basket, a cigarette, tomatoes, and a pepper. They're all members of the Solanaceae family. So potatoes and tobacco and peppers, tomatoes, eggplants are all part of Solanaceae, as is petunia. It's actually a very large family. It has a lot of interesting history. Medicinally, looking at this, and by the way, I have a audio and a non-audio version of all these lessons. The links work in the non-audio, obviously not in the video, but whatever. At least as far as I know, they don't. Maybe they do. Anyways, medicinal claims for Solanaceae family. So a lot of these traits are carried across the different species in the family. Treatments of burns and ulcers, antiseptic, anti-inflammatory, anti-dysenteric, fixes your Montezuma's revenge. Anti-tumor and anti-cancer. Wow, that's quite a claim. Anti-malarial, that's interesting. Rheumatic, pain relief. Lowers cholesterol, can reduce blood pressure. The list goes on, and it's so long, as I say there, I do have some doubts. Maybe we can find a cure for COVID-19 with the Solanaceae family. Maybe. I mean, anti-inflammatory, right? It's possible. Antiseptic, I don't know. Anyways, lots of interesting claims made. The link there is to a review paper that goes over some of them, and a lot of them are kind of legit. And I think I've said in the past, maybe you guys haven't heard as much from me because you didn't get Plant Science 1 from me, but pretty much every modern medicine was modeled after a molecule that came from a plant. So to some extent, there's got to be some validity, right? Moving on. This is sort of a familiar story here. It's kind of getting a bit embarrassing. Originally discovered in South America, right? You've heard this, right? They show up with their ship and they take their little prizes and they run back home. In the 1800s, it became an instant hit amongst wealthy gardeners. Obviously, no one else gardened because, like I'm joking here, right? They're either fighting or digging in a mine. But the reality was the average person didn't garden. They didn't have time or resources for that. But as far as petunias go, they can be found wild from California all the way to the bottom of Peru, or as I say, top, depends on which hemisphere you're from. But you haven't thought of that for a while, if ever. They like to grow in sandy soils, which means they need a fair amount of rain, but not too much. But they need really good drainage. That's critical. They can handle heat, which is interesting. From a gardening perspective, especially with hot summers. And they are moth pollinated. That's a picture of the moth. You can actually see it's quite a long, what are those? Forget my entomology days, proboscis or something, for probing the flower. The wild one in California, known as Calibrachoa parviflora, is quite small. That's a penny. So we're talking tiny little, but you can see the petunia-like flower structure. It's all there. Quite interesting. Then in South America, there's Petunia axillaris, which is white, a very upright growth habit. And then also in South America, there's Petunia integrifolia, which is where your purple colors originate from in the early breeding days. So how do we get to this? How do we get to the modern day petunia? So we cross-pollinate the three interchangeably, obviously not all at once. And through messing around, the Victorians and their wealthy gardening habits produced all sorts of bizarre things. All the modern dogs and cats we have, and a lot of the bred plant varieties that we have in our gardens all originated from what I call the idle rich in the Victorian era. Ironically, there was a controversy around petunias a few years ago because it was discovered that orange varieties of petunias were popping up in North America. They'd been in for sale in Europe already for a while, And someone happened to, I mean, not your average person, happened to do a genetic test and discovered that these were genetically modified to make them orange. It was a big kerfuffle. Plants were taken out of stores, fines were issued, and there was a lot of concern that these GMOs had been planted out in gardens everywhere. But lo and behold, the world didn't come to an end, and people garden quite fine to this day. So, maybe the alarmists could back off just a little bit. But I think it's extravagant to waste that technology just for a color, though. Let's be honest. Petunias, being close relatives to tobacco, are one of the most studied ornamental crops on the planet when it comes to academia. This graphic I grabbed shows you just how much studying's been done. Genes that control floral pigmentation, a lot of the studies were done with petunias. Understanding flower aging models and how to extend shelf life. The genetics of branching. Volatiles, terpene genetics, where a lot of studies were done on petunias. Understanding self-incompatibility. What makes a plant not pollinate itself? How is it done? How is that controlled? The list goes on and on. So there's quite a bit of research. This picture is actually a link to a paper that you might find interesting if you want to dig into it, but I won't ask anything for the exam. This is just a slide showing you a color chromatography of pigments coming out of petals from petunias. The coatings here are genes that are associated with the color renditions. So it's kind of interesting that some colors in ornamental flowers are produced not by adding a gene, but by knocking a gene out. Right? So if you take out the P1 gene, you're going to predominantly have a yellow colored flower. And so I ask you this question: is knocking a gene out genetically modifying or putting a gene in? Now remember, when you knock a gene out, you're not adding anything to the plant material. You're just cutting out a tiny little bit of DNA. That's an interesting debate. Not that I'm going to get into it with you online like this, which sucks, but, maybe everyone will stay happier this way. Okay. To modern day petunias, what do? We breed them, obviously, but we also do radiation and chemical mutagenesis. I realize that, and I know who I'm talking to here, you're going to be upset by all this behavior. It is bonkers, but the world makes a lot of money off ornamentals, and the buyers and the consumers are always looking for something new. And I kind of want to throw this back at the consumer, right? If consumers just said, hey, I'm happy with my violet colored or my pink colored petunia, can we just leave it alone? Then the farmers would be fine. They wouldn't invest all this money and time and energy creating weird, fanciful color configurations. But there you have it. So young seeds or plants are irradiated to create mutants, or chemicals are added to create genetic mutants. And then they see what comes out the other side. Even black petunias, although I technically should not put this on the slide because my understanding is that it was bred through traditional methods by overexpression of anthocyanin, so much so that it looks black. It's actually purple, but it's just so abundant that it looks black. That brings me to the wave petunia. I mean, maybe not everyone in the class has heard of wave petunia, but it's pretty popular. It comes with its entire branding. You buy the cuttings, you get advertising material, you get pots and labels and handles, everything, you name it. It's all marketing the wave petunia. Let's look now at the different types of petunias. So this is something that you should be able to converse in the horticultural world. Petunia grandiflora, multiflora, milliflora, and then, of course, spreading petunias. Let's look at them a little more closely. Obviously, there's a different size of flower and a growth habit. So grandiflora have large blooms, but they typically have weaker stems. So if there's a heavy rain, they bend over, they don't handle wind. Where multiflora are slightly smaller, these are the intermediate sized petunias. They produce more flower bud, so they're more ornamental, stronger stems, and the flowers can actually handle a heavy rainfall, which, petunias are pretty floppy, large flowers. When they get hit hard with water, they mat down and they'll often just sort of rot, and you have to wait for new ones to appear for it to look pretty. So the multiflora are probably more popular than the old style grandiflora petunias. The milliflora, which is also Calibrachoa, if you remember early on in the slides, I introduced one of the original genes, genetic parents was a Calibrachoa type of petunia in that family. These are often sold as Calibrachoa in garden centers, but they are a kind of petunia. And they're typically trailing, so they hang. They make really nice hanging baskets or planters where they trail over the sides. They're self-cleaning. So self-cleaning means that the flowers, when they're dead, they fall off. You don't have to go in there and remove them. They shed. The D is missing there, sorry. It's the smallest flower of the petunia family, and it definitely has the most flower buds. It seems that there's an inverse relationship. The smaller the flower, the larger the budding count. The bigger the flower, the smaller the bud count. And then, of course, there's the wave petunia, which is a ground hugging. You can see in this growth habit, it's sort of flat. It's not upright. Very vigorous. They are heavy feeders. They take a lot of fertilizer. For successful wave petunias, you need to incorporate some slow release fertilizer, Osmocote or something, and on top of that you want to do a liquid feed as well to keep them vigorously growing. They also require more water. Having said that, most petunias do not like a lot. That just means consistent moisture levels. These are medium size and self-cleaning, so they have a lot of positive attributes that makes them popular. As far as cultivation goes, we have both cuttings and seeds. Let's take a look at seeds. Similar to lettuce, these need light. There's actually photosensors on the exterior of the seeds, and they measure red light and far red light to germinate. They need to know that they are at the surface of the soil. If they're below the surface, they're too far for the emerging shoot to push through the soil. So they need to germinate near the surface. So they use light as an indicator of their depth. Bottom heat is recommended. Also watering from below, because you don't want to disturb them. Because typically if you take a surface dwelling seed and you shoot water on top, you're going to disturb the media, which would flip up and land on the seed. And you'll end up with, maybe they won't not germinate, but you'll have uneven germination, which we know now is a bad thing. So typically you would saturate your media seed and then put it in a germination chamber, which we've talked about before, and you get your uniform germination that way. That's anywhere from 5 to 15 days, depending on the variety. Once they're germinated, you need to get them in light quickly, or they stretch. And as always, we want sturdy stems, so we got to make sure we got light on them right away. And I'm not talking, a major amount of light, but certainly a certain, I would say anywhere from 100 to 200 micromoles to keep them compact. Looking at cuttings, which is kind of becoming popular again in recent years, there's this variety called Surfinia, which has a lot of really fantastic properties. Obviously apical cuttings for uniformity. These things root really easily. There's nothing spectacular here. Normal temperatures. What's kind of interesting is the temperature. We want to have bottom heat warm, and we want top heat cool. So this kind of creates a good rooting system, keeps it compact, and we also know that it actually shortens the time to flower. So it's a unique trick for petunias to have bottom heat and cool air. And then, of course, if you're late seeding and your weather's getting warm and you can't keep cool temperatures, you're going to have to get on the supplemental lighting to make sure they don't stretch, to keep them compact. So if you run cool air and bottom heat, you can save the electricity and not use supplemental lighting. Some of this applies to seedlings, as I mentioned here, like the stretch stuff. So cool air, warm roots, that applies to seeds as well. or seedlings. Okay, so growing on, it's important that you do not overwater petunias. This picture here shows you what happens when petunias are overwatered. They become small and spindly, they flower early. They're just weak, thin looking plants. Almost always too much water when you end up with this situation. The type and content of perlite depends on your peat moss. Different suppliers have different coarseness, so there's no standard. If you have a coarser peat, you can get away with less perlite, which costs less money for you as a farmer. So that's obviously what you want to do. Petunias like it acidic, more acidic than most bedding plants. If you're using water that's high in alkalinity or coir, you're going to want an acidifying fertilizer. They are heavy feeders. We're looking at 2.5 to 3 ECs, and that's pretty much constant. Feed almost every day. Nitrogen, potassium are equal. That's what we mean by a balanced fertilizer. Important note, sulfur deficiency. Petunias are the classic example of a crop that is sensitive to sulfur deficiency. If you're using city water, unless you live in Florida, it's usually very low in sulfur. So you have to make sure you have Epsom salts in your fertilizer program periodically to get that sulfur that's in the Epsom salts. So if you see general yellowing or weakness of your petunias, don't confuse it with nitrogen. It is sulfur. You need to make sure you get on your magnesium sulfates. Again, similar, cool air, warm root zone, supplemental lighting. What we did in the young propagating stage, you can carry through production for these things. Boron deficiency is another really interesting conundrum with petunias, which brings us to a little bit of a side lesson. Calcium is antagonistic to boron absorption. So if you are thinking, oh, I need lots of calcium in my fertilizer and dump lots in, you end up with a situation where the calcium is blocking the absorption of boron. And you start getting these mutated apical meristems and stunted, deformed growth. These are weak plants here, sort of sporadic. Looks really wet here, but this is a really good example of boron deficiency. If we look closer at the Mulder's chart, we can see calcium is antagonistic to boron, as is potassium, but calcium is a more pronounced effect. This chart, Mulder's chart, is an interesting one. I know you've looked at it before. Maybe some of you have forgotten about it. You may want to Google it up and look at it. It's very complicated. The more you stare at it, the more your head spins. But it is worth making a note of if you're looking at potential problems with deficiencies and you think you have enough fertilizer in your water, you may want to look at, in fact, that you have an antagonism happening. I know the weed guys like to call it lockout, but technically it's called an antagonism. So what's happy for calcium and boron? Really, it's obviously crop specific, but as a general rule, 300 to 1. And remember, boron's a micronutrient, right? We're not requiring very much. So 300 to 1, you got to go really high in the calcium to start messing up with boron. But there are some situations where people are adding more calcium than they realize, and they're causing more problems. And of course, calcium looks like deformed growth, so you might say, oh, we have a calcium deficiency, let's add more. And all you do is make it worse. So pay attention to your boron levels when you're looking at crops and deformed new growth. All right, what's wrong with this plant? So we've talked about this kind of thing in class. And what I like to remind you about with this picture is that we need to use our deductive skills here. This plant is looking reasonably happy, as is this group of plants. We have some problems here, and we have some problems here. This is uneven, right? So this may actually be a root health issue where maybe there's some pythium in the soil level because it's too wet, and these two plants are suffering, and they're luckily for you separated via the cell pack so that the pythium hasn't spread to the neighboring cells. But to say this is a nutrient deficiency would be incorrect, right? You say, oh, this is a boron deficiency. Well, clearly it's not, because they're both being fed the same thing, and this plant's fine and this one is not. So be sure to use logic when you're trying to ascertain problems with your crops. As far as pests and diseases, there's really nothing unique, so I'm not going to go through all the insects. That's just your usual suspects. One interesting note is that botrytis in the flowers causes spots. You see there's white spots all over this flower. That's actually botrytis. Below the root line, Phytophthora nicotiana. This is a Phytophthora that's specific to tobacco related species, and since petunia and tobacco are fairly closely related, this is a fungal issue for petunias. You can see that darkened stem near the base. As far as viruses, again, tobacco mosaic virus, TMV, this is what it looks like over here. You've got these sort of chlorotic patches in the leaves. That's your typical virus presentation for TMV and petunias. By the way, TMV and petunias is not that uncommon. There's a big purge happening with suppliers in South America. Guatemala and Honduras had some issues with TMV and were sending cuttings up, and some farms are close to food producing farms, and so the states get quite uptight about this impacting food production. So if you see this kind of thing in Ontario, we don't have any strict regulations around it. Obviously it's more your own economic damage, but be careful if you're finding this in your crop and you're near someone else who's growing Solanaceae type crop, right? Field tomato or something. Another one is impatiens necrotic spot, INS. We've seen this in other crops. These are these dark waterlogged patches in the leaves. That's necrotic spot virus. So that's another one to keep an eye out for. Obviously, with all these things, it's crop hygiene. With cuttings, it's about screening the cuttings and educating your employees to identify problematic cuttings early on if they can, to prevent it getting into your greenhouse in the first place. Interestingly, some petunias will actually self-pollinate, or if you have good, the right moth species in the area, they will pollinate. And this person's actually reseeded their driveway. And it doesn't look like they go in their driveway much because the plants aren't matted down. This is a picture of my ideal garden. It's all evergreens and maybe one petunia basket on top of a statue. This is not my backyard. Trust me. That'd be hilarious. But it's not.